Agora eu gostaria de passar a palavra para a professora Inês, da Universidade. A professora Inês é professora Inês Lopes Matos Carneiro, de Faria, coordenadora de programas do programa de pós-graduação do curso de Direito na Universidade de Brasília. Professora Inês, muito prazer em estar em a senhora moderar esse evento, tudo bem?
Tudo bem, muito obrigada, Emerson, por participar aqui, só ressaltando que aqui na Faculdade de Direito nós temos o grupo de estudos em transportes e também o grupo de estudos em Direito Internacional, Aéreo e Espacial, então estamos aqui integrados junto com o grupo também, muito obrigada.
Muito alinhado. Ontem mesmo eu estava conversando com a AEB durante a manhã, a gente já está formatando o evento do ano que vem, e com certeza teremos um painel na área de direito espacial, né? Semana que vem até eu estarei em Brasília, quem sabe a gente pode se encontrar para conversar um pouco mais sobre isso. A gente acaba um evento e já está pensando no outro, né?
Será um prazer, né? Eu acho que nós temos que justamente capilarizar e integrar os grupos de pesquisa em diversas áreas, né? Um setor que tem muitas áreas que dialogam e transversais também para o desenvolvimento de toda essa área, seja da área de governos ou áreas comerciais também. Muito obrigada.
Exatamente. Bom, Inês, você pode ficar à vontade agora e conduzir esse primeiro painel, tá bem? Fica à vontade.
Ok, muito obrigada. I'd like to make an introduction in English, if you allow me. First of all, I'd like to thank you very much for the Mundo Geo and also the Brazilian Space Agency for inviting me to moderate this panel with so brilliant experts. And I'm also so pleased to join this webinar. And I'd like to greetings to all of experts on this panel. So to start our event, I'd like to invite Pam Underwood. She's a director of the Office of the Spaceport of the Federal Aviation Administration, FAA. So for us, it's a pleasure to have you here, and thank you very much, and the floor is yours.
Thank you very much. Inez, I appreciate it. Thank you for the opportunity to join everybody today. I hope you can see my screen. I'd like to share my slides for my presentation.
Yes, we can see it.
Very good. Okay, well, thank you so much for that introduction, and I appreciate the opportunity to talk with everyone today. My name is Pam Underwood. I'm the director of the Office of Spaceports at the Federal Aviation Administration in the United States. Today, I will be talking with you about licensing from our office for commercial space transportation activities, the process to do that, and the international partnership we look forward to having with Brazil and the Alcantara launch site. In the United States, the FAA has the authority to license commercial launch and reentry activities as they're carried out by citizens of the United States. The mission that we've been given is to ensure the protection of public, property, national security, and foreign policy interests of the United States during commercial launch and reentry activities. We're also responsible for encouraging, facilitating, and promoting the U.S. commercial space transportation industry. To date, the FAA has licensed over 400 launches and reentries since 1989 without any public casualties or major property damage. It's quite a record. Our industry is growing at an exponential pace. Just this year, we exceeded 60 launches for the calendar year, or approximately one launch per week, which is a new record for our office. And the industry is only growing and getting more exciting and dynamic in the future. In the United States, US law requires any citizen or entity organized under the laws of the United States To obtain a license from the FAA to launch or re-enter a vehicle either inside or outside the United States, or to operate a launch site either inside or outside the United States. This means that all launches by US citizens in other countries also require a license from the FAA. We also have an approval called an experimental permit, which is a little different than a license. It's used for suborbital reusable vehicles, and any US entity must also get a launch license from the FAA in order to conduct a launch of a reusable suborbital vehicle. The FAA does not have the authority to license activities that are by and for the US government. So if there is an activity that is conducted by a US government entity for a US government entity purpose, the FAA does not license that. We are solely focused on commercial launch and reentry activities. As I mentioned earlier, the cadence of launch activity is increasing. We set a new record this year with over 60 launches this calendar year in year 2021. You can see in previous years, dating back to as early as this chart shows, in 2011, we had approximately one launch and in single digits for several years thereafter. So to reach this type of milestone, approximately one launch or reentry per week, is a really exciting time. And we only expect to continue to have increases in the coming years. It's important to note that this total includes launches of US operators both inside and outside the United States. We currently have one launch operator, US operator, conducting launches from New Zealand, and that is included in this total. The commercial space transportation industry is a growing global market, and we look forward to having licensed launch activities in other countries as our industry pursues global markets. Sorry, it looks like my screen might have frozen. Here we go. So this is the process to obtain a license in the United States. It really starts with, over on the far left hand of this chart, some initial discussions. That's a phase where a company comes to just tell us what they would like to do. We consult with the company as they start to work on their application. This allows us time to understand the activity, their vehicles, and the very safety critical elements of their operation. Once a company officially starts working on their application, we move them into what we call stage one, which is pre-application consultation. During this time, the company and the FAA have a series of technical interchange meetings as the company prepares their analysis and application for FAA review. Once the application is submitted to the FAA, they enter what's called stage two, or application evaluation. The FAA, by US law, is required to complete a license application review in 180 days, or 120 days if it's an experimental permit. During that time, the FAA conducts reviews of critical safety analysis, airspace clearance, environmental, as well as financial responsibility requirements. All that is completed during the stage two, or license evaluation phase. At the conclusion of 180 days, the FAA will render a decision about a license application. If the application is approved, then the vehicle operator can move into what we call stage three, or operations. This is where they conduct the activity that they proposed and received approval from the FAA. During this time, the FAA continues to monitor compliance through safety inspection, which is on site. We typically have 1 to 2 safety inspectors monitoring safety critical activities during the operation. At the conclusion of the operation, you can see the cycle then starts over back into pre-application consultation and so on. But this effectively is the process to get a license from the FAA. This chart is the same. It describes the same process, but gives you a little bit more detail about what specifically work on during each phase. As you can see, during pre-application stage 1, before the application submitted, we start very early on 3 key elements: safety review, environmental review, and airspace and waterway integration if waterway is a factor for the proposed operation. Some of those discussions and reviews take longer and need to be started immediately. Therefore, we try to make sure that we have our focused discussion with the applicant as soon as they start to prepare their application for review. During stage 2, you can see those 3 main element reviews continue: safety, environmental, and airspace and waterway. But we also start a policy review, which is an interagency review of the proposed activity with other U.S. Federal entities. We also look at, as I mentioned before, financial responsibility, and of course, a review of the payload for any safety critical elements that might be contributing from that payload. All of those reviews take place during that 180-day evaluation. At the conclusion of that 180 days, of course, is when we need to make the determination of a license. And if a license is approved, that's when they enter stage 3, which is the operational phase. And of course, as I mentioned, we have safety inspection and compliance monitoring that proceeds during that stage. I wanted to talk with you guys a little bit today because as our industry grows global, the FAA sees a great opportunity for international partnerships between spaceports. The FAA would like to promote our regulations as a model for other countries to consider as they're looking to develop space laws of their own. Common requirements between our countries promotes interoperability for our industry and will also promote that global commercial space transportation industry growth that I spoke of before. In addition to common requirements, the FAA would also like to reduce duplication between international governments. For example, for a US launch in another country, the FAA, by our laws, is required to issue a license for that activity. We would like to work with the other country so that we're not duplicating approvals and reviews. Duplication between countries does not increase safety, but it can be stifling for the industry that we hope would grow and continue to grow globally. The FAA currently has operations that are conducted outside the US by US operators. As I mentioned before, a company called Rocket Lab is launching from New Zealand on a regular basis. And we have many other US companies that are exploring potential launch locations outside the United States. This really underscores the importance of international partnership for these activities. And it's imperative that the governments start to work together to promote interoperability and partnership, reducing duplication for the activities. The US, if it's a US entity conducting the activity outside the United States, they will, of course, have to follow the US law. But the FAA would not license the spaceport, the international spaceport, unless, of course, it's being operated by a US entity. At the present time, we don't have that under proposal, so the FAA would not be licensing the site, rather just the operations at the proposed international location. I appreciate the time to talk with you guys today. I wanted to give a little bit more resources for anyone who's interested. Here's some website location to find out more information about a license and permit applications. There's guidance material, and of course, a link to our regulations, the 14 CFR Port 400. You can find all of our regulations listed there. And that concludes my presentation for today. I'll stop sharing my screen. And I look forward to the discussion and any questions from the group.
Thank you so much, Pam Underwood. It was really great to think about how to promote commercial space transportation, and your quick view about the steps that the license should get. And it's very interesting to see the timing around 120, 108 days, what is amazing. And it's very nice to see how you can, the obligations that to monitor it, and also to keep watching how these movements of transportation is developed. And also I highlight the international cooperation among countries to develop new launches and new space objects on the space, and also the international partnership together with government and enterprise to make sure that we're going to develop a very commercial space transportation in a manner that everybody is going to benefit from that. Thank you so much. And continue, the questions will be at the end of the 3 presentations. So I'd like to introduce the next panelist. That will be Alejandro José Roman Molinas. He's the General Director of the Aerospace's Execution and Development of Paraguay Space Agency. He is not here in person, but he's kindly sent his presentation to present to all of you here. Thank you so much, Alejandro, for this kindness to participate virtually in this panel. Thank you.
Good afternoon. Thank you very much for the invitation. My name is Alejandro Roman. I am representing the Paraguayan Space Agency. Let me share my screen. Today, I want to share with you the 3 years of work of the Paraguayan Space Agency. Since the beginning of our work, we are focusing in the development of the aerospace sector in Paraguay. First of all, I want to express my sincere gratitude for the invitation and this event to Mundo Geo and the Agência Espacial Paraguaia. It is an honor and pleasure to share the floor with distinguished colleagues here this afternoon. Let me start talking about some numbers. The aerospace industry is a growing economic sector in the world. We have now about $400 billion of turnover in the global space economy. Looking at the nanosatellites launch in worldwide, we see that our region still have a modest participation, and even the prediction, the forecast of the launches is growing exponentially. In this graphic, we can see the total participation of the launches in South America and Central America of nanosatellites is just 1.6% of the total worldwide. We are living in a changing world. The pandemic and the climate change it represents a major challenge to us, and to respond to this challenge, we need to have a better decision-making process. The satellites have a major role in this. In this video of NES, we see the launch of one Earth observation satellite. The space offers a new perspective of our world. It helps us to understand, to measure, to modulate, to forecast the planetary dynamics, and to help the emergency situations. We are changing the planet. We are affecting the ecosystems, and the humans are responsible but also victims of this climate change. The satellites help us to better respond in case of emergencies, as we will see in a few minutes. The Paraguayan Space Agency started to work in this area with other space agencies through the international charter of space and major disasters that we will see in a few moments. Then the satellites help us collecting a big amount of data and to have access and to bring the benefits of space. We need specialized institutions like the Paraguayan Space Agency, and we need to involve the universities. We are working very hard on this direction. We are aware about the benefits of space in telecommunications and the Earth observations in the positioning, weather, and navigation services. Also in the research and production of the scientific knowledge in the microgravity environment. And of course, the observation and exploration of the universe is helpful to expand the scientific knowledge. And the satellite data are a powerful tool to achieve the SDG. Then why develop aerospace science and technology? Because they are generator of productive transformations and accelerator of scientific, technological, industrial, commercial, and social development of any country, especially developing countries like Paraguay. We have two lines of development. One of them is capacity building in basic space engineering. Our first satellite is a flagship. And the other line of development is the Earth observation applications in many areas, in emergencies, floods, fires, storms, in agriculture, in cadastre, in deforestation, water resources, critical infrastructure, panoramic epidemiology, and territorial planning, and others. Looking at what we have done in these 3 years in Earth observations, we started with emergency. 2 years ago, we have a very big flood affecting 100,000 people in our country. We declared a state of emergency, and we activated for the first time the International Charter for Space and Major Disasters. That makes us have access of a very important amount of data. When the floodings were over, we started with the wildfires. We activate again the International Charter of Space and Major Disasters, and we worked with many institutions in the government, in the academia, and the private sector in Paraguay. We are actively access the portals of information like CONAE in Argentina, like Copernicus in the EU, and INPE, and of course NASA. We are actively using the portals of the Fire Information and Resource Management System, for example. And with this data, we managed to collect and to produce a unified daily report. That daily report goes to the press, to the decision making, to the general public. And this represents a coordinated effort in the response in case of emergency. Those are the space agencies that collaborated on this disaster charter. We are part of this working group to provide the better data to the decision makers here in Paraguay. The president of the Paraguayan Space Agency on this image is delivering the data to the Minister of Emergency here in Paraguay, not only in the digital format, but also in the physical format to be used in the field. And we are working in the Earth Observation Laboratory and Geographic Information Systems, and on all the areas that I mentioned before. This is our GeoLab. This is a very new initiative of the Paraguayan Space Agency, and we are working to develop pilot projects especially in emergency agriculture, deforestation, and other areas. Also in the health, we have worked very close with the Ministry of Health here in Paraguay. For example, in the visualization of data, here we have a hotspot map of the city of Asunción, where we can see the incidence of the mosquito, Aedes aegypti mosquito environment. This is very helpful to help the National Health Authority to take decisions in which area we need to prioritize the countermeasures or preventing measures in case of the mosquito. We have a very close collaboration with NASA. We are receiving many data and models. We are working with other institutions, especially in disaster area, and we are providing the possibility of have access to forums like the Earth Observation Forum. This is the second year that we have done the Earth Observation Forum in Paraguay. Also, NASA provides us, for example, historical data of wildfires in our country of the last 20 years. This work was done with the University of Idaho, the Michigan State University, as a result we asked for this information, and NASA provided us with the help of this university. We are working also in many other areas. We participated in a hackathon in Taiwan. It's a KiloCube robot challenge. Our team wins in Taiwan the competition, and we have the third place in the international competition. Also, NASA selected the Paraguayan Space Agency and the other 10 institutions as a global partners of the NASA Space App Challenge this year. And we are participating also with another 8 countries in the common projects to share spatial data, satellite data, for example, the project series. And we are participating very, very actively in the communities of space, like UNSPIDER, GEO, AmeriGeo, in the United Nations, in the International Federation of Astronautics, and the International Academy of Astronautics, in the Latin American and the Caribbean Network for Space, and the PDC and other areas. We are focusing very hard in training for our colleagues to have the best training to access and to provide best tools and best opportunities to develop the space sector in our country. We are working with institutions in the government sector in Paraguay, with academia. We are very close relationship with academia, and NGOs and other institutions on the private sector. Talking about the airspace development, we have the Paraguay to Space project that put our first satellite in orbit. This is a development from our country. This is the patch of our first mission. It's a 1U CubeSat, and we are following a success model of development, like the Costa Rican case. We joined an international cooperation group with the Kyushu Institute of Technology in Japan. And from March 2018 until this year, we developed the project and we complete the mission from the design until the engineering model and the flight model. And we have on February 20, we have the launch of our first satellite. This was followed by 2.9 million people here in Paraguay. We developed a TV show, a TV program of 3 hours to promote this event, and it was a huge success and a huge impact here in our country. 2 days later, the satellite arrived to the International Space Station, and in the 14th of March was finally put it in orbit. And the space segment has 3 satellites, the Paraguayan, Filipinas, and Japan satellites. And the main objective of this mission is the capacity building. We have another 10 missions, and one of them has to be with the public health, as we will see in a moment. The ground segment, we have installed traps to detect a vector of the Chagas disease in the indigenous community here in Paraguay. The Chagas disease is still a problem in the region, and it has no cure. We can just only work in the prevention. This is a position of the traps in the Paraguayan map, and all the system has renewable energy, like solar energy. We have this is the community, the schematic of the community: 55 houses and 20 traps. The objective of the traps is to detect the presence of the vector. And we are also installing our first infrastructure, like Operations Monitoring and Control Center in the Paraguayan Space Agency, 2 ground stations, one in the University of Asunción, another one in the Paraguayan Chaco, as we will see here. We are working with this indigenous community, and to make possible this ground station installation, we have sent 3 engineers to Japan. We have a very big social work also with the communities. Here we are explaining to the community how this program will benefit the community, and we help to prevent this disease. And this is the moment that our ambassador in Japan received the flight model of the satellite, and those are the certificates that JAXA give us as evidence of completion of all the tests and requirements to the launch. The timeline was completed without major problems, and those are the institutions that help us to develop this project. We are very focusing also in training, dissemination, and international presence in many countries like Colombia, Russia, France, United States, Peru, Mexico, United Arab Emirates, Brazil, Chile, United Kingdom, and of course in our country, to make the people understand why the space sector is so important. For us, the projection for 2021 is a new alliance, new challenges, of course, new projects. And in conclusion, we can say that in 3 years, the Paraguayan Space Agency joined the biggest and the most important forums in space in the world. We have participated in the most important events related to space, and we are working with the most important space agencies in the world. All this thanks for the teamwork and the commitment of all the members of the Paraguayan Space Agency. The exploration and use of outer space is for all countries and is a patrimony of all humankind. Space is for everyone, and it's imperative to leave no one behind. Thank you very much. I will more than happy to answer your questions offline. Thank you very much.
Thank you so much, Alejandro, for bringing the development of the space policy in Paraguay. And you start showing that just 1.6% of the total world comes from is launching satellites from South and Central America. And also you finish your presentation with the pointing out the access to space to all countries, to all people. And thank you so much for this. And also it's very interesting the strategies to develop space policy in Paraguay, such as capacity building, and also showing how the space contributes to development of Paraguay, such as the Earth observation, and also the need for better infrastructure to make sure that Paraguay join the space activities, and also training students, and also engineering and other workers that needed to contribute for space development. So thank you so much for your presentation, and thank you very much for kindly ask for people, and you answer virtually for any questions that come from this webinar. Thank you so much. I'd like for the next step will be our last presentation. And before that, I'd like to invite you all, if you want to make any questions, please send us through the chat. And there is a part that you can make questions for all participants. Thank you so much. Now, I'd like to pass the floor to Luciano Giesso, Diretor Internacional de Vendas, Satellogic, the Argentina. Thank you so much for your participation in this webinar, and thank you so much, and the floor is yours. Thank you.
Muito obrigado, Inês, e muito obrigado, Emerson, e a toda a equipe de Mundo Geo. E também quero fazer um agradecimento muito especial para o Henrique Fernandes Nascimento, da Agência Espacial Brasileira, que foi quem sugeriu meu nome para participar hoje. So I'm going to switch to English now, and I'm going to share my screen. I hope you're seeing my screen right now. Inês, could you please confirm?
Yes, sim.
Perfect. Perfeito. Ok, então vou falar um pouco de. I'm going to talk a bit about Satellogic and where we stand today and where we're heading. Satellogic is a vertically integrated geospatial analytics company. That means that we look at the Earth from space, and we do it with our own fleet of satellites. So first of all, I'm going to talk about what we are wanting to achieve and where we're heading. We are really growing at a pace of becoming a live catalog of everything on Earth. What we like to say is that we are creating a searchable Earth, and you know, the uses of Earth information and of data that comes from space are very vast. My previous colleagues talked a bit about that today, but we're looking at really being able to look at the Earth in real time. And at the end of the presentation, I'm going to show you a bit of a roadmap of how we think we're going to get there. So this is how a snapshot of our company looks today. Our founders are Argentinian. I myself am Argentinian, and I'm based in the US. But our founders founded the company 11 years ago in Buenos Aires when we first started. These two guys came from the IT industry. They were highly successful entrepreneurs from another industry, from another technology industry. And a lot of what we do, and I'm going to give you some examples in the presentation, has a bit of a heritage of how we did things in the IT industry. So again, we're 11 years old, a bit more, so we have learned of the space industry a lot along the way, but we didn't have a previous footprint in the space industry, and many of the 300 people that you see over here that are working in Satellogic today, most of us come from the IT industry. Again, I'm going to give you some examples of how we translate some things of that industry into the space industry. So the cities that you see here in the map are cities where we have offices. The pandemic has taught us that we can work remotely, most of us, most of the time. So we have people working in about another 35 cities around the world, and in many countries in the world where we don't necessarily have an office. Some of these specializations that we have in each of these offices are: Argentina is where the engineering team is, and the operations teams too. These teams are, one of them, engineering, is in charge of designing and creating every new generation of satellites that we launch. And operations in Argentina too is the team that is looking at every satellite that we already have in orbit. We launched 25, as you see over here. They are looking at, telemetry and movement and conditions of every satellite that has already been launched. So those two teams are, majorly based in Argentina. Then we have an office in Montevideo, Uruguay. That is where we have our AIT facility, our assembly, integration, and testing plant. This is where we build the satellites in a free zone in Uruguay. That gives us a lot of good conditions in terms of cost. Then the third bigger office, I didn't mention it, but Argentina has about 150 people. Uruguay is about 50 people. Barcelona is also about 50 people big. And this is the office where, when a satellite captures an image and downloads it into a ground station and we're ready to process it and send that as a finished product to a client, that is what the Barcelona team does. Okay, so they're the downstream aspect of the whole end-to-end value chain of our services. Then we have an office in Tel Aviv that does software development. We have the office that I am in Miami, which is a commercial office, and we have many other commercial people working in the United States and also in different places in Europe. And then we have our main office in the US, is our office in Charlotte, North Carolina, where we have our finance and control team. So that is where our main firm in the US is based. But we also have a federal firm in the US. So I myself, I do the international market, but there's a president of a national federal company that is based in Seattle, and that's the federal company that we use for working especially with the US government. For anything other, we have different firms and places in the world, but the company that employs me is another US company. So we have two companies in the US, one international, one federal. Last but not least, we have a team in China that is majorly based for that market and some places in Asia. But outside of that one, every other location has very much of a specialization, meaning that what's done in Argentina, it's mostly done here. What's done in Barcelona is mostly done there, and so on and so forth. And that allowed us, during the past year and a half, to work under pandemic circumstances pretty seamlessly. So we didn't have an impact because of the way we were used to work, office to office, in how we do things because of the pandemic. So is that last year we launched more satellites than we had in the previous 10 years of our existence. And we have grown in 2021, we have grown more this year than we have in the previous, in every other year combined over our first 11 years. So I mentioned that we launched 25 satellites to date. I'm going to talk a bit about that further in the presentation. We're launching the next 4 in the first half of next year. We've been launching with SpaceX since June this year, so we'll be doing this launch with SpaceX again, probably in April next year. And a lot of what we do and the way that we keep our costs low has to do with the fact that we invent and we patent everything that we, every invention that we do. So to date, we have had granted 11 patents in different places in the world, 6 of which were granted in the US, 1 in Europe, 2 in Israel, and 2 in Japan. We have about 35 patents that are awaiting granting, and about 50 to 20 inventions that will undergo the patenting process after. So we build a satellite that is very, very cost effective. This is how it's seen. It's very, very cost effective in the way that we do it, and given the high, level of technology that it carries. I'm going to go back to the cost in a second, but let me talk about the satellite for a minute. So the satellites carry two cameras here. One is a multispectral camera mounted into the main telescope of the satellite, which is the center of the satellite over here. To give you an idea of size, it's 90 centimeters high times 50 times 50 centimeters, okay, about the size of a chair, okay, to give you an idea of dimensions. And this camera here can do up to 70 centimeter resolution imagery, which is very, very high, as satellite imagery goes. And then we have within the same vehicle, within the same bus of the satellite, we have another camera mounted over here, which is a hyperspectral camera that can see in 29 bands instead of the 4 bands that the multispectral camera has, and has 25 meter resolution. So this camera actually allows to see, to tell us a healthy crop from a sick crop, or to tell different levels of water in different soils. And this other camera sees very closely. So with the two cameras equipped within every satellite that we have, we can provide solutions to clients using the best of both worlds, the one that sees very closely and the one that sees in a special way. We're doing video, by the way, with this camera too. We're doing 60-second video with this camera. And to give you an idea of some hard specs, the mass of the satellite is about 40 kilograms. We orbit in low Earth orbit, sun-synchronic, at about 475 kilometers from Earth. This has to do with, these two things have to do with our IT heritage, okay? So when we started doing satellites, what we wanted to disrupt, and the way we thought that was a way of keeping technology updated, we had to keep costs low if we wanted our satellites to be constantly renewed, okay? What we want is our satellites to be orbiting for the same time that you have your cell phone or your computer with you before you change it. So we want the kind of pace in which Earth technology changes to be the same kind of pace in which our technology in space changes. So what we do basically is we build a satellite with enough batteries to last only for 3 to 4 years, with enough butane in the propellant tanks. They have their own propellant in the back of the satellite to only last for 3 to 4 years, for the whole outside of the satellite to resist the sun radiation and the hostile conditions of space for no longer than that time. So everything costs are lower in that sense because of a mandate, because of a philosophy that we have of building a spacecraft that is going to be replenished constantly, and that we don't want it to be orbiting like in traditional, space. In the traditional space industry, a satellite would be orbiting 15 to 20 years. Well, we don't want that. We need to have constantly renewed technology as fast as possible. And that is why we build them and lower costs as an advantage to that, for them to only last 3 to 4 years. And the other thing that I'd mentioned before, that we patent everything. We don't buy components from anybody. We have everything as our own design. We don't outsource any design of the satellite. And that allows us to drive costs very, very low too. So in the end, what we have is a satellite with extremely high resolution imagery, and with this hyperspectral capabilities, plus video, plus this other bay that I didn't speak about, and I'm going to touch base later, for a cost that is between 100 and 1,000 times less than a traditional satellite. To give you an idea, a traditional satellite ranges somewhere between $200 million to 500 million or 800 million, even $1 billion in terms of cost. We're building a satellite and putting it in orbit for less than $1 million. Okay, so that is the kind of orders of magnitude of difference in which we build our satellites versus the traditional industry. So to give you a snapshot of what the story was, and a look at our history and how the launches were and what the satellites were named. The first names that you see over here are, we named the first satellites after Argentinian names. If you can recognize some of those, thank you very much. But as of February 2018, we started naming the satellites after women in science, or women in STEM. So Ada Lovelace is this Ada that you see over here. This is Mariam, for Mariam Mirzakhani, an Irani mathematician that died very young. Sophie Germain, Marie Curie. Then we have many others. Cora, some of these are Argentinian here. Cora is Cora Rato. a mathematician and human resources activist of Argentina, and so is Elisa Bakoffen here. Elisa was the first civil engineer in Latin America, and she's Argentinian too. I promise that we'll name one of them after some Brazilian woman in science. We have this idea of naming the next 100 satellites after women in science, and we're choosing the names for the next 4. And next year we're launching a bunch of satellites. You know, we have a number of pre-agreed launches with SpaceX already. So there will be occasions for us to name them after, you know, Brazilian women in science and other Latin America women in science too. The generations that you see over here, so we had 10 launches with different satellites in each of those launches. As you see, in recent times, we have been launching more and more satellites in the same rocket. And every generation, as of the start of this architecture that we call new sets, and it's the one that I described in the previous slide that measures 90 centimeters high times 50 times 50, and this is about the size of a chair. Every generation of this ones was better as we went one after the other, as you see here, Mark 1, Mark 2, Mark 3, etc. But we're staying within this architecture because it really works for us in the sense that it's not a CubeSat like these that wouldn't allow for the kind of high precision imagery that we're capturing, and it's not a 2-ton satellite that makes for a much higher cost. So the 10 that you see in these pictures here are the 10 that we launched back in November, all together in the same rocket. It was too many chips in the same basket, and we were lucky, and we were always lucky, and we had successful launches all the way, and I cross fingers for them to remain that way. But you know, 1 every 50 missions fails, so we won't do 10 together in a single rocket again. With SpaceX, we agreed to launch, in each launch, we're going to do 3 to 4 satellites, you know, at the higher, you know, we won't do more than that per SpaceX rocket point forward. Again, we are launching the next 4 in the first half of next year. You know, this is a more visual picture of the names that you saw in the previous image, and we're looking and we're choosing the 4 names that will be launched in the next launch, and that we will name the next satellites after. We did this poll recently at GeoInt, which is an event that happens every year in the United States, organized by the National Geospatial Intelligence Agency. And in that event, we had this urn where people voted for names. So we're going to pick from there, and you'll know about the next names probably early next year when we have them selected. By the way, and I'm gonna say this as the last thing within this this thing about naming the satellites. I'm a big music fan, and I vouched for women in rock and roll. I still wasn't listed within Satellogic, but I'm doing my push. I hope that we have, you know, some satellites named after women and still women, but not necessarily women in STEM, but women in rock and roll in some upcoming launch. Okay, so satellites are in orbit. What do we do with them? Okay, so what I'm going to tell you and show you now is a bit of what we do after the satellites have captured an image. What is the kind of value that we provide to our clients, both in the private sector and in the governmental sector. By the way, some of the images I showed in the presentation, this one is a very nice one from Rio. This is only a portion of the image. The image is much bigger, but this is the kind of imagery that we do. So we basically divide our offering portfolio in 4. The first product is pretty obvious, of course. We do images, so imagery is the first offering that we have. We're providing imagery to clients in the governmental and private sectors, you know, all around the world. In all 5 continents we have clients, and we have a lot of traction with multispectral 70 centimeter resolution imagery, as well as with hyperspectral imagery that doesn't abound much. So we're doing a lot of that. We're starting seeing more demand for video lately. But again, this is like our main, and what makes us really unique. We have really high resolution, high frequency, low cost imagery. So that is what we're working more in along with this, which I'm going to get to. Second product is AI solutions. Images, as you may know, are only a means to an end. If you make sense out of the images, then you can make decisions that help in your business or help in your in different uses of satellite imagery all around the world. So we have a department of data scientists that makes sense out of the images by applying artificial intelligence and machine learning to the images, and helping our clients with reports that say, for example, for an agricultural company, where a given crop is growing better or applying a nutrient work better in this area than this other, or we can tell an oil and gas company, well, they had an oil spill, or we can monitor the places where ducks are passing, or we can tell a city where a given urbanization is growing faster, so they can estimate the number of inhabitants of a given area and how it's growing by revisiting points of interest with a given frequency. The way this works is we capture repeated images of different places in the world, and we compare, and we do this all with AI and machine learning. We don't do any kind of manual inspection of imagery. We compare images of the same area with a given frequency, and algorithms educate themselves to understand relevant changes and be able to inform and to give conclusions to our clients with that. Third product, and as I mentioned when I was talking about imagery, first one and third one are the ones that we're more focused on today. This is something that we call dedicated satellite constellations. It is a bit of a space as a service or a satellite as a service. The way this works is Satellogic is not invested or focused on selling our satellites. We don't sell hardware like the traditional industry would do, but we rather sell services with the satellites. And what we mean by that, and what this service actually is imagine you could use a fleet of our satellites while the satellites are orbiting above your country or above a given region or above a given city or above Amazonia, whatever that would be. What we do is we offer the country the ability, and by offering the ability, we put every ground segment component in country for them to be able to do this, to operate our satellites while the satellites are going above their land, and to relinquish the use of the satellites when the satellites exit, say, the northern frontier of the country, and we use them for something else up to that, as of that point. What it means is you don't buy a $200 million satellite or invest in a $100 million satellite, but you, for a much, much less money, because we would only charge you for the time that the satellite is above the area of interest that you want to see, be that your country, a given city, or a given area. You only pay for that time, and we don't give you one. We give you as many as you want, depending on the kind of frequency that you want to have on that area of interest. So the places in the world, we signed a couple of contracts on this already, and the places in the world that we're monitoring are places where a given observation satellite would be orbiting those lands less than 1% of their total lifetime. So the thing with satellite, with observation satellites is they're orbiting Earth. Ours orbit typically in polar orbits, meaning that the Earth is turning below. And if you're looking at me, I'm trying to do it with my fingers here. What happens is the satellites are looking at different places in the world in every turn. So it's very ineffective if you want to have an observation satellite to basically, or to mainly look at your country, or to mainly look at certain areas of interest, say as, Amazonas or Sao Paulo, or places that would be of more frequent interest to the country than the whole globe. It makes a lot more sense to contract a service where we give you the use of the satellites than to buy a single satellite, and for these countries, the countries that we have in place are with 12 satellites and with 10 satellites. So they're using a lot more capacity and they're able to do a lot more and for a lot less money with much more satellites than they would be able to do if they bought a single satellite from somebody else. So when we launched this service back in 2019, we made the finalist list of the satellite technology of the year, and that sort of confirmed that this kind of service makes sense. And again, when I mentioned before that we have this IT heritage, well, today in the IT industry, companies, IT companies are less and less selling boxes and selling servers, but they're selling cloud services where you pay in a subscription mode for the use of IT data. Well, we're translating that into space by doing a subscription model for use of satellite technology. Last but not least, this is, and I didn't mention anything about this yet. Imagine you had a sensor that you want to, that you developed, and you need a satellite to carry it. We give space of our satellites and we sell a given area of our satellite to carry third-party sensors. And we have 2 contracts in place already. And we did a pretty nice thing in Argentina a couple of years ago. There's this foundation called Open Space. That is an Argentinian foundation that set up end of 2019, and it went all, no, it was beginning of 2020, I'm sorry. This was a contest then went on during most of the year, where students of Argentinian technical universities were encouraged to participate and build a sensor that would be built into, that would be incorporated into one of our satellites. There were 300 teams that participated. Not all were Argentinians, because this was founded by the country and by the city of Buenos Aires. There was a condition that 2 students out of every team had to be Argentinian, but we had Brazilians, we had Uruguayans, Paraguayans, Bolivians, Peruvians, Chelsea sensors in our satellite, and we call it Hosted Payload Program. Okay, I'm going to go through these pretty quickly. It's just to give you an idea of some images and contracts that we have with different places in the world and what we're doing. These images have to do with monitoring boats and ports and containers in ports. This is sort of similar, but with planes, both in airports and in this, which is it's a plane graveyard. Actually, they're using these planes to replace parts of their existing fleet. These are more urban, looking at growth in buildings or green areas within cities. This one has to do with monitoring the speed of passing of cars, in a given area. We're doing video here. These are more agro-related mostly. This one is in Brazil, Ortigueira. This is a forestry sector of Brazil. This is more agricultural. This is a national park in California. This one is mining. It's a different thing in Botswana in Africa. These are hyperspectral. Okay, the colors that you see are corrected for our eye to understand what the camera is seeing. This is not real, of course. There's no purple in Bangladesh, but we're doing these images and doing services with hyperspectral imagery here. My colleague from Paraguay, Alejandro, mentioned their lineage with a disaster charter from the United Nations. We're a part of that club, if you will, too. And we do a number of things looking, not commercially, but looking at helping in different places in the world with satellite imagery whenever there's a natural disaster, such as an earthquake or a flood or a fire, in this case, a volcano in Guatemala. These are daily images that we have been taking of the Pacaya volcano in Guatemala. We collaborated with these both for the disaster charter and for NASA Disasters, which is another organization looking at disasters around the world. This is another example where we were monitoring, the aftermath of the explosion in Beirut in Lebanon. This one, this one I actually posted here, not because we did anything useful with it, because they had this problem completely identified, and there's images from everywhere of the Evergreen when it was stuck in the Suez Canal. But because every other company, every satellite company went out and got an image of the Evergreen, and people started tweeting and comparing the images, and we came out, informally, we came out as first. I'm going to tell you something formal about our multispectral imagery later. But people really vouch for our image versus others, so that is why I included here. So the last 2 slides. First of all, I want to tell you where we stand and where we're going. I told you that our satellites are decommissioned after 3 years of lifetime. So you see here that we're using 17 out of the originally launched 25. We're actually using today 17. And this is the way before somebody asks, and typically I get this question, when I talk about decommissioning satellites, what we do is we bring them closer to Earth until they burn in the atmosphere, okay? They're orbiting at about 27,000 kilometers per hour. That is about 8 kilometers per second. If we lower that kind of speed, they start getting closer and closer to Earth in every turn and end up burning in the atmosphere. That is the way. We do not leave any space debris, or we don't use any graveyard orbits to decommission our satellites. To date, we have already decommissioned date. Again, within this mandate that we have of keeping technology updated at all times, and we don't want any of them to live for more than 3 years. So we're using 17. We plan to launch a bunch next year and so on until we get to our ultimate goal, which is having 300 satellites at all times. And when I spoke at the beginning of creating a searchable Earth, well, this is how we are, we're on our path to achieve that. To give you an idea of revisits today, we can do up to 4 times per day revisits of points of interest with a constellation that we have today. That means that we can, and this is especially useful in the case of the disaster charter, whenever a natural disaster happens around the world, we can revisit those places every 6 hours, and with that being able to provide imagery to help with boots on the ground and land help as fast as possible in the areas that are more effective after the disaster occurred. So today we're having this kind of revisit, which is very, very frequent for the industry, 4 times per day. Our intent and our ultimate goal is to pretty much look at the Earth in real time, which is what's going to happen here. We would be able to look at the whole globe once a day when we get to the 300 satellites. That is having a picture of Earth complete every day. And last slide, I just wanted to give you a couple of recent news. First of all, we're going public by the end of the year, anytime now. We announced this a couple of months ago, but we're going to be quoting in NASDAQ by the end of the year. Our ticker symbol will be SATL. Then, another thing that we pretty recently announced, we have been users of AWS cloud services for a while, but we announced, a partnership to develop their ground station solution, which is sort of a virtualization of the ground station infrastructure, which makes a lot of sense for us because we're so oriented to services and to subscription models to get into a subscription model for our ground segment too. So that is the second announcement here that I wanted to mention. And the third that I just gave a hint when I showed the evergreen on the Suez Canal. In the last NGA event, the National Geospatial Intelligence Agency from the US, they had this GeoInt symposium happening in St. Louis a month ago. We got the gold medal. They do this Olympics-like contest, and we got the gold medal for multispectral imagery, on a global basis. So that was confirming and a very nice recognition for us to know, how good our imagery is ranked, amongst different peers of the industry. So that's it. I'm open to questions, and thanks again very much for having me here today.
Muito obrigada. Thank you so much, Luciano, for this lovely presentation. I will turn in Portuguese to make sure that there are lots of questions in Portuguese too. And if need, we just change Portuguese and English. Muito obrigada. Eu acho que você trouxe várias questões sobre a perspectiva das empresas nos negócios espaciais, e isso foi muito importante para saber como é possível desenvolver novos negócios no mundo espacial. Gostei muito quando você também trouxe a inserção da mulher e trouxe aí várias personalidades femininas que têm contribuído para o desenvolvimento da indústria aéreo e espacial também. E também com relação ao trabalho que é desenvolvido, é muito interessante dentro dessa indústria 4.0, observar como os satélites são importantes para várias coisas que as pessoas mal possam imaginar do que é possível a gente utilizar com a tecnologia de satélite, não só da perspectiva do estado de desenvolvimento, monitoramento da sua agricultura, do seu clima, com relação às monitoramento com o uso de tecnologias para controles do movimento de aeronaves, etc. Ao mesmo tempo, traz uma perspectiva de como o cidadão de cada país pode se beneficiar dessa tecnologia espacial. Como você bem apresentou, isso também foi um ponto apresentado pelo Alejandro na questão da agricultura, você pode inclusive utilizando a inteligência artificial e a machine learning, de você ter um relatório de como tem sido desenvolvida a sua indústria, né? E isso é importante. Assim como a Pam também trouxe a importância de como as atividades espaciais no lançamento de satélites, é importante ter esse passo a passo, né, e um espaço razoável de apresentação do projeto e de análise dessas empresas que querem participar. Ao mesmo tempo, eu gostei muito da apresentação da Pam, quando ela coloca a separação muito bem delineada de que essa licença para o espaço-porto é uma licença para os negócios comerciais no espaço, separando os interesses de governo, os interesses de Estado e focando especificamente com as atividades comerciais. Isso é importante para dar segurança e previsibilidade aos investidores neste assunto. E fazendo um tangenciamento entre as três questões, e uma das perguntas que foi feita é uma das perguntas que eu vou conectar também com a minha, com relação à questão ambiental e à sustentabilidade, né? A Pam colocou que dentro do licenciamento existe uma análise ambiental, e aí e, ao mesmo tempo, ela coloca que, em média, dentro desses espaços-portos nos Estados Unidos, tem sido uma média de lançamento de 1 por semana. E você, Luciano, também colocou a questão no seu gráfico, ainda mais no final, desse aumento substancial de pequenos satélites que têm uma vida mais curta. E uma das perguntas que o nosso público faz é exatamente com relação a sustentabilidade no espaço, né? E aí a pergunta que a pessoa faz, eu vou complementar, é no sentido de, aqui a Melânia coloca o seguinte, are you asking in English? Because she's speaking, she wrote in English here. She said, my internet has frozen the screen and audio, so I don't know if this question has already been answered, but I will ask anyway, since your satellites have a lower life cycle, do you have any plans to remove them when they are decommissioned and so as not contribute to space pollution? And together with this question, does the FAA has any policy for removing space debris when a company is authorized to launch a satellite? Thank you so much.
Pam, if you want, I can grab the first one because it's more pointed at me, I think, and you can
Yes.
do the next one. Okay.
Yeah.
Ok, Melania, eu vou tentar responder em português. Eu mencionei isso em minha apresentação. Nós, o que fizemos é os satélites têm sua própria propulsão. Então, o que fizemos quando o satélite está aproximando-se ao fim da vida, e movemos o satélite mais perto da Terra para que a gravidade comece a ganhar em cada órbita que o satélite seja mais perto e mais perto da Terra. E termina se queimando completamente, desintegrando na atmosfera, tá? Não há nenhuma parte do satélite que vai resistir ou passar por a atmosfera a reentrar no espaço atmosférico prévio a entrar na Terra. Então, nada queda e não deixamos nenhum tipo de debris, nem tampouco fizemos nenhum tipo de o que se conhece como graveyard orbits ou como órbitas tumba, que outras tecnologias satelitais se faz, que é mandar o satélite a flotar ao outro lado. Não fizemos isso. Desintegramos o satélite completamente na atmosfera quando já chega ao fim da vida.
Thank you so much. Pam, please.
Yes, absolutely. Thank you. So the FAA, the FAA does not have what we would call on-orbit authority. So at the present time, the FAA's authority is limited to launch and reentry. As far as satellite or removal of debris, that is currently outside of the FAA authority. There are some United States policies about orbital debris mitigation and how to handle orbital debris or aging or inactive satellites, but that is not something that is governed by the FAA. The United States government is working very hard to look at different ways to handle orbital debris in the future, and we look forward to having these kinds of discussions with our international partners.
Perfect. Thank you so much. Now I'm switching to Luciano, and after you make another questions to Pam. Fernando Iodi say a resolução temporal é inversamente proporcional à resolução espacial. Como o satélite mostrado apresenta sensores multiespectrais de ótima resolução lógica, que ele demonstrará para fazer a revisita, e em quanto tempo estamos falando? E a cobertura de imageamento é mundial?
Ok, sim, perfeito. Hoje temos a capacidade de poder fazer revisitas de pontos de interesse do planeta até 4 vezes ao dia, tá? Então, se há uma área que quer ser revisitada com esse tipo de frequência, a gente podemos ter, com nossa constelação de 17 satélites atuais, podemos fazer revisitas da mesma área até 4 vezes no mesmo dia, tá? Satellogic tem sua constelação distribuída em distintos planos e com satélites equidistantes um do outro, de modo de não ter uma área do mundo prioritária sobre outra, tá? A revisita é constante e é igual, não importa o lugar do mundo que fora.
Perfeito, muitíssimo obrigada. Duas perguntas a Pamela, uma da Amélia Honora, e a outra de uma pessoa anônima. A primeira pergunta diz: quais as principais dificuldades enfrentadas pela FAA no processo de autorização? E a segunda pergunta em inglês: after the FAA issues an operator's license, under what circumstance can be withdrawn? How did SpaceX violate its license earlier this year? Thank you so much. The floor is yours again.
Thank you. And thank you for those questions. For the FAA, the biggest challenge we face right now is keeping pace with our industry. Our industry is growing at an exponential pace. They're innovating and creating technologies that are really very exciting and advancing quickly. We as regulators need to make sure that our regulations can keep pace with that. In December of 2021, we released in December of 2020, so it was last year, my apologies. We released a regulation for launch and reentry, an updated regulation aimed at doing exactly that. It's a performance-based regulation versus a very specific regulation like we had previously that will allow our industry to innovate and our regulations to be able to keep pace. It's a very exciting time in our industry, and these types of things as regulators, changing our approach to enable the industry is really important. To the second part of the question about what circumstances could occur that we might be able to change a decision about a license after it's issued. As I mentioned during my presentation, the FAA does compliance monitoring after a license has been approved or issued. At any time, we can suspend or revoke a license should we have questions or concerns that we need to discuss with the operator. And that is what our safety inspection element of our process is for, making sure the license is being conducted in the manner in which we approved it. And that's a great partnership that we can have with our industry to have the dialogues to promote understanding and greater safety. Unfortunately, I won't be able to speak specifically on the SpaceX incident, but I do appreciate the question. But the answer still remains. We have compliance monitoring after the fact, and that allows us to have a great dialogue and a great partnership with our industry to promote safety in this exciting, growing element we're in.
Thank you so much. I'd like to make some more questions that are in our chat. The first one is, does cooperation continue to be an important tool for development of programs and projects in the space sector in the global panorama? And the second question is, how is it perceived by both the private sector and the public sector, the importance of having policy documents for realization of international projects, whether with investor or with other countries? Thank you so much. The floor is for both. Thank you.
You want to go first?
Yes, please.
All right. Oh, okay. Okay, I'll go first. So, on the first question, yes, I think this is, I would say it's the industry where you see cooperation happening between nations and between different entities within nations, which is more pronounced than any other industry that I've worked in or than we see in many other industries. So there's a lot of things happening. You saw when our colleague from the Paraguayan Space Agency mentioned the kind of cooperation that as an agency and as a country they have with other countries in the world. That is impressive. Even in the private sector, of course, we have competitors, but we're, there's a lot of projects where we work together with other companies where, we would otherwise be competing in a different opportunity. So I think there's a lot of cooperation here. I think space is like giving humanity a new opportunity to look at things in a different way and try to compete less and cooperate more. So that would be my stab at the first question. On the second one, I would say that we are very much regulated by different entities in the world. And that there is, I make a distinction there with our federal company in the US. We're very much more aligned with the FAA and PAM than we are in the other, in the other side of the business, where we're a bit more aligned maybe with entities that have, that are depending on the United Nations. But in everything, I think there is a huge amount of regulation that we have to abide by, and that is a good thing because the space industry is growing at an amazing pace these days, and we're happy to do it. It's it makes sense that we start putting our things in order and looking at from where a given satellite is to be orbiting to the kinds of places where we are to be obtaining images from and not. There's a lot, in our niche or in our industry, we look at that with a lot of caution and a lot of seriousness. So there is I would say there is a big importance in the sense of abiding by regulations in space.
Thank you so much. Luciano, now Pam, please.
Thank you. And I agree with Luciano. Cooperation for space internationally is very exciting right now. As the industry continues to grow globally, what I'm really enjoying is the opportunity to work with other government agencies in promoting common safety and approaches for the industry. It helps all of us if the industry grows and has a common set of standards, much like we've had on the aviation side for years. The space needs to work in that direction too. We can take a lot of examples from our aviation colleagues. Look at what they have today in aviation for aircraft certification. There are agreements in place between international governments so that there's no duplication of effort between countries when it comes to aircraft certification. One country will accept another's. Same thing goes with the fact that there are common safety practices and processes for the execution of aircraft certification. That's where we need to get to with space. We need to have common approaches, common regulations, and then of course work together as international governments to have some kind of recognition models in place. Now that's going to take some time to get there. Aviation's been working on it for, 30 or 50 years, and we're just starting. But it's definitely the vision we need to look towards. And I think it's a very exciting time. So I couldn't agree with Luciano more. Cooperation for space is definitely important right now and an exciting place to be.
Thank you so much for your answers. I think by the end, Pam highlight the need for an international organization with the power as the civil aviation, International Civil Aviation Organization has, that unfortunately UNIOSA doesn't have the same power to harmonize all laws, so assure for business, for private sector and government, laws that are very clear to make business work well. Thank you so much. And I think Emerson is here to say it's a lovely time, but it's time to end. And thank you so much. Thank you so much. I will say em português, Luciano e Pam, e também ao Alejandro, que não está aqui, mas esteve aqui conosco virtualmente. Para mim foi um prazer enorme, aprendi muito com vocês e espero vê-los novamente em outras oportunidades e agradeço imensamente novamente esse convite e fico feliz de ter compartilhado este momento com vocês. Muito obrigada.